Hello, this is Mr. Stansbury. I'm going to take you through some of the worked problems from 10H. Okay, so here we have number 2. Probability that it is cloudy on a particular day is 0.4. Probability it's cloudy and rainy on a particular day is 0.2. Find the probability that it will be rainy on a day when it is cloudy. Okay, so what's important to remember is probability is what you want to happen over what could possibly happen. Okay, so now the key here in this one is says find the probability that it will be rainy on a day when it is cloudy. So we know for sure that it's a cloudy day. We're not even talking about the like sunny days or whatever. So that means the possible, our probability on this thing here, the possible is going to be just the cloudy days. That's what we're choosing from. So the possibility that it's cloudy on a particular day is 0.4. So that's the only possible. And then find the probability that it will also be rainy. So it says find the probability it's cloudy and rainy on a particular day. That's what we want to happen. And that's the 0.2. So 0.2 divided by 0.4 is going to give us 0.5, or simply 50%. Okay, or 0.5. Either one is fine. Okay. Okay, next one to take a look at is number 5 here. 50 hikers participated in an orienteering event during summer. So there are 50 total hikers in this box. 23 were sunburnt, and there's 23 in this circle total, both of these regions. And then 22 were bitten by ants. So 22 were bitten by ants here. And 5 were both sunburnt and bitten by ants. So there's going to be a 5 in the middle there. Draw a Venn diagram to display this information. So we know there's 23 total in here. If there's 5 already here, 23 minus 5 gives us that this here has to be 18. And then same thing for over here. 22 minus 5 gives us that this here has to be 17. Okay? And we know that all of these 3 plus this outside here have to add up to 50. So if we do 18 plus 5 plus 17, let's see, it gives us 40. So that means that there are 10 people out here that were neither sunburnt or bitten by ants. Okay, so part A, draw a Venn diagram. Done. That's honestly, this is the hard part. Once you get this taken care of, then these questions should be pretty quick and easy, hopefully, to answer. Okay, so part B, determine the probability that a randomly selected hiker avoided being bitten. Okay, so the only ones that were bitten by ants were these 5 and so these 22 people, right? So the other 18 and 10, the other 28 did avoid being bitten. So 28 out of the total of 50. So let's bring our calculator up here and come up with that. So we do 28 divided by 50. And that gives us 0.56. So probability, we could do 0.56 would be just fine. Or we could also do 56%. Okay. Probability that they were bitten or sunburnt. Okay, so that would be sunburnt or bitten by ants. So that's going to be all of these except for those 10. So that would have to be the 40 out of 50, which you divide that out and you get 0.8 or 80%. Okay. So part 3 here, we're running out of room up there, was bitten given that he or she was sunburnt. Okay. So given that they were sunburnt, so only choosing out of these 23 people, how many of those were also bitten? It would be those 5 out of 23. Okay, so again, bitten given that they were sunburnt. So we're only choosing from the sunburnt people, which is all 23 of these. How many of those were also were bitten? Just those 5 were bitten by ants. Okay, so we do 5 divided by 23, and we get 0.217, so we'll say 0.217 or 21.7%. And then part 4 here, What's the probability that they were sunburnt given that they were not bitten? So here's the people that were bitten. So the people that were not bitten are the 28 out here. Okay, how many of these were sunburnt? Of that they were not bitten. So sorry, that's this group here. How many also were sunburnt? These 18 out of 28. Right? So we do 18 divided by 28, and we get 64.3, 0.643, or 64.3%. Okay? Let's take a look at number 8. Urn A contains 2 red marbles and 3 blue marbles. Urn B contains 4 red and 1 blue. Peter selects an urn by tossing a coin and then takes a marble from that urn. Figure out these probabilities. So here's what I'm going to do. I'm going to do you can do this several different ways. I'm going to do it with a tree diagram. So it says that Peter selects an urn by tossing a coin and then takes a marble from that urn. So let's say that if he tosses heads, he's going to choose urn A. And if he tosses tails, he's going to choose urn B. So the probability that he chooses A is 0.5 because it's 50-50 chance that you'll get heads, and then that means that a 0.5 chance that he'll choose urn B. Okay. Now once he's chosen urn A, he can either get a red marble or a blue marble out, right? So we can do red marble and blue marble. So red there are 2 out of 3. So 2 out of the total 5, 2 out of 5 is 0.4 probability that it'll get red. That means the other 3 out of 5 are going to be blue. So that is 0.6. Remember, these numbers on each set of branches, they always have to add up to 1. Okay. And then this is going to be red and then blue. So this is urn B. There's 4 red and 1 blue marble. So this 4 red is going to be 4 out of the total 5. So that is 0.8. That means the other 0.2 is blue. Okay. Now, we haven't actually answered either question, but just by drawing out this tree diagram is going to make it a lot easier to answer these questions. All right. So, A, determine the probability that the marble is red. So that would be, let's do this. That would be this branch right here, or it would be this branch right here, right? So determine the probability that it is red would be 0.5 times 0.4, because both of these things have to happen, right? And then we also have to have, it can happen this way too, 0.5 times 0.8, okay? So this gives us 0.2, this gives us 0.4. So either this could happen or that could happen. So we would actually take the 0.2 and add the 0.4, and that gives us 0.6 would be our probability, or 60% probability. Okay, so that would be for part A. Okay, for part B here, let's choose a different color here. Part B. Given that the marble is red, what's the probability that it came from urn B? So part B, we know for sure it came from, that it's a red marble. So given that the marble is red, this here is going to be our denominator. So what's the probability that it's going to be red? That's that 0.2 and the 0.4, which we just figured out in A. So that means the denominator here is going to be 0.6, because we know that it has to be red. So there's 60% of the time it's going to be red, but we know it's red. Now, what's the probability that it came from urn B? That would be the 0.4. So we would take 0.4 divided by 0.6, and that is going to be what? 2/3, which is 0.667, or 66.7%, either way you want to look at it. Okay? Okay, let's look at number 7, and we'll be done. All right, in a certain town, 3 newspapers are published. 20% of the population read A, 16 read B, so forth and so on. Use a Venn diagram to help determine the probability the person reads this stuff here. So we now have 3 newspapers, so we need a triple Venn diagram. Okay, so here we have a triple Venn diagram, and the big key, if you remember from the regular Venn diagram, we always try to fill up the middle space first here. Same thing with a triple. We want to fill in this middle space here if we can find it, and that's usually going to be at the end. So here it is. 2% read all 3 newspapers. So there's 2% in here, right here. And then, let's see, 4% read B and C. So these 2 regions together here have to add up to 4. So since we already have 2 here, that's going to be another 2 here. Okay. So that's that. And then 5% read A and C. So these 2 have to add up to 5. So 2 plus 3 will give us 5. And I like to cross them off as I go. Then I know I've covered everything. 8% read A and B. So there's 8 between these 2. We've already used 2 there. So that's going to be 6 here. Let's see. 14% total read C. So there's 2, 4, 5, 6, 7 already total. So there's another 7 to add up to 14. Let's see, 16% read B. So 6, 7, 8, 9, 10 already here. So that means 6% read just B. And then 20% read A. So 6 plus 3 plus 2 is 11. And we know there's 20 total. So 20 minus 11 leaves us with 9 in here. Okay, so now we know this is who read what. So like, for example, this here, these people just read C. These people read C and A. These people read A, B, and C. Okay, now we also need to figure out how many people didn't read any newspaper, right? Because we know that since it's a percent, we know that all of this has to add up to 100%. So what we want to do is add all of these numbers up here and then figure out what the difference is from 100. Okay, so added all these numbers up here and got 35. So since there's 100 total in that, 100 minus 35 is going to leave us with 65. So there's 65 people or 65% of the people didn't read any of the 3 newspapers. So use the Venn diagram to determine the probability that the person reads none of the papers. We just figured that out. That is 65%. At least one of the papers. That's all of these. So that was the other 35% right there, right? Exactly one would be these 3, because these people read just A, just B, just C. So that's going to be 9 plus 6 plus 7, which is going to give us 22%, I believe, right? Yeah. A or B or both. So that's going to be everybody that's in these circles here. So it's basically the 60, probably the easiest way, instead of adding all those up, is I'm going to take 65 and 7. 65 plus 7. Those are the people that don't read A or B or both. And that is going to give us, what, 72. So now I do 100 minus 72, and that gives me 28%, which would be the same as adding up 9, 6, 6, 2, 2, and 3, which probably would have been that difficult anyway. Let's see, part A. Sorry, E. How many people read A, given that the person reads at least one paper? So now we got to start calculating some stuff. So the people that read at least one paper were these 35 people. And how many of those also read A? Well, we know that 20% read A, so we've got 20 over 35. Okay, so now we'll just want to go through and calculate that. So we do 20 divided by 35. We get 0.571. So 57.1%. Okay. What's the probability that a person reads C, given that they read either A or B or both? So that's all of this group right here, which we just figured out A or B or both was 28. So how many of these people here also read C? That's 2, 4, 5, 6, 7 out of the 28. Which is 7 out of 28, that's a quarter. So it's 0.25 or 25%. Okay? All right, that's the every other problem from 10H. If you have any further questions, please feel free to ask. Thanks.